Hi everyone, my name is Petson Gidi. I'll be your driver as we go through the entire geography syllabus. Just in case you're a bit nervous, a bit worried about getting lost, don't worry, everything will be fine. I've got the whole map digitized already in GIS. I also have the GPS for us to see all the directions. So relax, everything will be well. I hope you're going to enjoy this, and this will be crucial as you prepare for your final examinations. Enjoy it. Welcome to Geography. The topics we will cover are physical geography and people and places. Themes addressed in physical geography will be climatology and geomorphology. Those under people and places include settlement and South Africa. The map work will be handled separately, but will also appear at relevant intervals within the other topics. In this first section on climatology, we will explore cyclones, the effects of the plateau on South African weather, including berg winds and line thunderstorms, as well as microclimates, valley and city climates. In order to understand cyclones, we need to take a look at the planetary wind system. Remember that maximum heating takes place at the equator, and only a small amount of heating reaches the poles. This results in a surplus of heat in equatorial regions and a deficit of heat at the poles. As you know, nature cannot abide an imbalance, and therefore it attempts to sort this out by moving warm air to the poles and cool air to the equator. If you look at the non-rotating Earth, you will notice that the air rises over the equator, that's ascending air, as a result of heating, causing a low pressure on the ground. As it reaches the tropopause, some air moves north and some south. This air starts cooling and sinks, causing a high pressure, more or less over the tropics. Some of the cooled air then returns to the equator, and some moves towards the polar circles. This first circular motion that is completed is called the Hadley cell and is purely a thermal cell. At the poles, the air sinks because it is cold and heavy, causing high pressure on the ground, that is descending air. This air moves towards the polar circles, but as it is cold and heavy, it forms a wedge. This wedge forces the warmer but still cool air from the tropics to rise over it, thus completing the polar cell. Because the air is rising, this is a region of low pressure. As the air reaches the tropopause, some of that cool air moves back towards the tropics, completing the Ferrel cell. Please note, on a non-rotating Earth, air would now move from the high pressure belt directly to the low pressure belt at the right angles to the pressure cells. But the Earth does rotate, as does the air mass above it, and there is a strong correlation between these movements. As air masses move over the surface, they move to areas of different rotational speed, with the equator moving the fastest and the poles the slowest, causing a deflection from their path known as the Coriolis force. Coriolis force can only act according to Ferrel's law, which states if you stand with your back to the high pressure, wind is deflected to the left in the southern hemisphere and to the right in the northern hemisphere. If you look at the names given to the planetary winds, they are common sense to remember. If they blow from the east, they are easterlies, and if they blow from the west, they are westerlies. So we have one set of westerly winds in each hemisphere and two sets of easterlies, that is, tropical easterly winds blowing from the tropics to the equator, and polar easterlies blow from the high pressure at the poles towards the polar circles. In the southern hemisphere, The tropical easterlies are also known as the southeast trade winds, and in the northern hemisphere, they are known as the northeast trades. It is important that you know about these cells and winds as they form the basis of cyclonic and anticyclonic movement. In reality, the pressure belts are not snake-like lines around the Earth, but appear as pockets of air that rotate around the planetary cells, with the winds moving inwards to a low pressure and outwards from a high pressure. These pockets of air form cells known as cyclones and anticyclones. If the cell has a high pressure, it is known as an anticyclone, and if the cell has a low pressure center, it will form a cyclone or a low pressure cell. You will note that the isobars are drawn to show atmospheric pressure. The lines showing pressure on the synoptic map are isobars, and they work in a manner similar to contour lines. The bigger the unit in hectopascals, the higher the pressure. The smaller the number, the lower the pressure. We have seen how the planetary winds are the major controls of global weather patterns.
Really, really good. Yeah. Really good.
Silence, please.